Inside a wind tunnel for skyscrapers. Have you ever thought about how tall buildings can stand up to strong winds high above the city? What happens when the plan of a building is put to the test by nature before it even goes up? Come with us as we show you inside a wind tunnel, where engineers and builders test new ideas to make sure that our tall buildings will last. How do they make it look like hurricane-force winds and make sure our city's tall buildings are safe? Keep reading to find out the secrets behind the tall buildings that make our towns what they are. You probably picture things that move very quickly when you think of an advanced wind tunnel testing facility. For example, aeroplanes or Formula One cars are examples of high-speed vehicles. However, they are also essential to the design of skyscrapers, which are among the largest and most magnificent buildings in the world. Yes, wind tunnels were used in the design process for every single one of the world's tallest skyscrapers. It is necessary to have them in order to accurately estimate the effect of wind loads, demonstrate that intricate architectural concepts are actually feasible, and guarantee that individuals will not be swept off their feet. In order to provide the B1M with an exclusive opportunity to see their world-leading test facility and model workshop, RWDI, which is a global leader in this particular industry, received an invitation. Their wind engineering teams contributed to the construction of a number of buildings, including the Shanghai Tower, the Petronas Towers, and the Burj Khalifa. But how exactly does everything function? Now is the time to take a tour of this cutting-edge structure, which is sure to be an exciting experience. Where would you begin the process of designing a brand new skyscraper that is very tall? There is, without a doubt, a great deal to take in consideration. To design and construct it, you will want a significant amount of material, a substantial amount of money, and a large number of skilled individuals. In addition, the location is an important consideration. A dynamic metropolis such as Dubai, Kuala Lumpur, or Shanghai would be an excellent option. Another essential aspect that must be taken into account is the way in which the structure reacts when subjected to strong winds. This aspect becomes increasingly significant as the height of the building increases. Calculating it can be a challenging task, and it is necessary to have cutting-edge technology, such as the kind that is available at the Advanced Wind Tunnel Test Facility in Milton Keynes that is owned and operated by RWDI. At this location, teams construct models of buildings and then place them on a turntable that is located at the back of a wind tunnel. After that, wind is blown onto them at varying speeds and pressures, and it is applied to the model. Sensors located within the model are able to pick up and gather data regarding the manner in which the form of the building and the shape of the building are reacting to the wind. After that, they provide it to the design team so that they can shape and decide what the appropriate appearance of a building should be. If you were to look at any tall building in the world, you would notice that almost every skyscraper would have been put through a process similar to this one in order to ensure that it functions properly before it is actually built. First and foremost, safety. What makes this procedure so important when it comes to the design of a contemporary skyscraper? In light of the fact that if you do not give wind loading and aerodynamics a great deal of consideration during the construction process, it may result in significant problems, and you will also miss out on some significant advantages. The associate wind consultant at RWDI, Fabio Faceley, stated that safety is definitely a crucial aspect, and that the second main aspect is carbon footprint and cost. Therefore, by utilizing wind tunnel tests, it is possible to optimize the design and potentially save approximately 25 to 30% of the embodied carbon when looking at the facade and the structures. With that being said, how powerful is this wind tunnel? The fact that we are unable to achieve the same speed in a wind tunnel as we do in the real world is not something that should come as a surprise to anyone. As far as Faceley is concerned, the problem is simply one of scale. It is possible for this one to attain a speed of 16 meters per second. The fact of the matter is that you are going to have a higher wind speed. Hence, we need to increase almost everything. Therefore, before we proceed any further, it is important to point out that the practice of installing wind tunnels on buildings is not a novel phenomenon. Since the 1930s, researchers have been conducting wind experiments on models of skyscrapers, including model versions of the Empire State Building. Since the original World Trade Center was thought of in the 1960s, wind tunnels have been contributing to the actual design of tall structures because of their ability to reduce wind speeds. In light of the fact that skyscrapers have become not only taller, but also more architecturally ambitious, it has become a critical matter to ensure that they are capable of withstanding severe winds before they begin construction. With the help of these tunnels and models, architects, developers, and other businesses are able to truly comprehend and even visualize the impact that the wind will have on their structure, creating a microclimate. But it's not just about what wind does to a single building. You've got to look at the bigger picture as well, because planners also have to assess what would happen to the surrounding environment when a construction is created. To provide one example, the wind effects created by London's new skyscrapers have become a huge discussion point in recent years, and it's also produced a lot of work for RWDI. We're wanting to consider not only if the wind environment is going to be safe for a person walking around the building, or indeed users of the building on higher levels, but also if it's going to be comfortable and just a nice place to be around. Jennifer Lowther, RWDI's technical development lead, explained, "When we're testing a building, we obviously test it without anything just to see what already exists. But then we also test it with the proposed development with all of these buildings in situ. And then we will also test it with future buildings, which means that we will test it with future structures that have been consented to, just so that we can understand what those future scenarios are going to look like as well. At this point, we are aware of the capabilities of those wind machines, as well as the purposes for which they are utilized. Nevertheless, what about the real models? Who or what is the origin of them? That would be an additional component of the same establishment, which is the model shop. In this location, specialists are able to devote months to the creation of extremely realistic reproductions of a wide variety of structures, not just skyscrapers. Some of them are manufactured using a 3D printer, while others are constructed using a variety of materials, including resin, plastics, and timber. We are working on projects in every region of the planet. Dubai, China, New York City, and the City of London are just few of the places where we have worked on projects. Harry Dooley, the leader of the UK model shop at RWDI, disclosed that there is a wide range of everything, ranging from the smallest to the largest and everything in between. At the present, we are most likely working on 10 or more live projects. This is something that we are always working on. Everyone is always busy, and at the same time that things are being completed, we have tasks that are on their way, right? In other words, our work evolves in tandem with the progression of the globe. Heroes without fame. Whenever one thinks about skyscrapers, a number of things spring to mind. These include the architecture, the construction process, the cranes, the steel, and the fundamentals of traditional engineering. However, these unsung heroes are responsible for guaranteeing that a wide variety of buildings all over the world are genuinely viable. They are ensuring that these buildings are able to stand on their own. They are making it possible for us to have skyscrapers. This goes to illustrate, once again, the power of this business, the tremendous diversity of occupations that are accessible in this industry, and the incredible people that put so much effort into making our built environment a reality. If you enjoyed this deep dive into the fascinating world of wind tunnels and skyscrapers, make sure to hit that subscribe button. Don't miss out on more behind-the-scenes looks at cutting-edge engineering and architecture. Subscribe now for more exciting content.